Dr. V. Chandra Jagan Mohan. Today we'll discuss about the wind energy. So, as you already know, uh, we are having different sources of producing the power. So, both with renewable and non-renewable. So, among the renewable sources, the first thing we have habituated to produce the power among the renewable sources is the first thing is the wind energy. So, wind, as you know, everybody know the from olden days we were using the power of the wind for different purposes, for sailing the ships, for windmills, for grinding, for pumping the water. We were using these for different applications. So modern days, in the search of producing more power, the alternative powers than the renewable sources, and we have came to this option of producing the wind, producing the power with the help of the wind. So this is also one of the major source. At present, may not be dominating the renewable sources, may not be dominating the thermal power, not yet. But these renewable sources in future will dominate these non-renewable sources. So among the renewable sources, the wind energy is the major thing. So if you think of producing a power, electrical power with the wind, everyone, a common man thinks, oh, so we are producing wind with the help of the power. How can we produce the power with the help of the wind? Yes, this is also possible. So there also we are using the fan. Here also we are using the fan, which is called as the wind turbine or the windmill. Okay, so there we are producing the wind. Here we are producing the electricity with the help of the wind, movement of the wind. So what is the wind? The movement of air. The movement of air with some kinetic energy. So that we are calling it as the wind. So once we are going to construct a wind turbine, so it will be having a fan-like structure, wings. So that is also different wings. So in olden days we were using different wings on different purposes. So the optimal nowadays, the optimal thing is that it's better to use the wind mill with 3 wings, so which will have a good efficiency. So here we'll be having these blades. Yes. So these blades will rotate. Whenever the wind touches these blades, there will be at one side of the blade there will be difference between the pressures than the other side. This makes the turbine to rotate or lift or drag. Both the lift and drag forces will come into the picture whenever the wind touches the blade of a wind turbine. So, but the lift force dominates, so that's why the turbine will rotate. So, whenever this is rotating, this fan is rotating. So, this is connected to the generator. This is connected to the generator where we are going to produce electricity. This is a normal thing. So here the input is the wind. So if you go to the hydropower, the input is the hydro. That's why we call it as hydropower. So thermal power, the input is the steam. So in all these cases, the turbine is the same thing. We're using the turbine, and we are connecting the shaft of the turbine to the generator. So only up to the input is varying. Remaining everything is same, almost same. The way of taking the power, way of capturing the power is varying from hydropower to thermal power to wind power. Remaining the thing of working, that is rotating, all these things has remained the same. So if already I have told you the movement of the air, some force or some kinetic energy, we are calling it as the wind. So some people may get doubt why these winds, what is the cause for occurring of these winds, what is the cause behind this movement of air or wind. So there are majorly three reasons why the wind currents are formed. The sun is heating the atmosphere or the earth, so it will not heat uniformly throughout the atmosphere of the earth. That is the first reason. Because of the rotation, inclination, all these things are the reasons. And the second thing is that the earth surface is not same everywhere. It is having different geographical structures. At one place there will be sea, at one place there will be hill, at one place there will be desert. There is so much of differences, irregularities on the earth surface. This is the second reason. And also the third reason is the rotation of the earth. So one side only it is going to face the sun. The other side it will not face the sun. The rotation of the earth. So these are the reasons behind this formation of the winds. So first thing is the sun, who is heating the atmosphere unevenly, and irregularities on the earth surface, and the rotation of the earth. Okay. It's just what is the thing which is making a wind turbine to rotate? The same thing, the aerodynamic force from the rotor blades. So these blades, the construction of these blades, the angle of these blades is very, very important to make sure the aerodynamic force. So it's just like how it is going to happen for the helicopter or like an aeroplane. So one side the both sides of the wing will not have same pressure. They will be having a difference in the pressure. So that is the key here. That's why it is able to move. This difference in the pressures is making this wing or the blade to rotate, or the wind turbine to rotate. So when the wind flows across the blade, the air pressure on one side of the blade decreases. So that means the both sides there is no equal pressure. The difference in air pressure across the two sides of the blade creates both lift and drag, but the lift will be more. So the force of lift is stronger than the drag, and this causes the rotor to spin. So the lift force is dominating ultimately here, so which is making the turbine to rotate. So the rotor of the turbine is connected to the generator. So and finally the rotor of the generator is going to rotate and creating the flux, creating the power, generating the power. So this translation of aerodynamic force to rotation of a generator creates electricity. So the wind energy here is converted into the electrical energy. So this is the key thing here. So in the hydropower, the water energy, the energy in the water is converted into power. Here the energy in the air is connected to electrical power. So in this there are different types of modules based on the different conditions in that particular area. So the main two types of the wind turbines are horizontal axis turbines and the vertical axis turbines. The most commonly we were using the wind turbines are the type of horizontal axis. So this is the most popular thing which we are using. Commonly we can see. So you can observe here. This is the normal horizontal axis. So you can observe its axis is horizontal to the earth. Okay, its axis. So this horizontal axis turbine you might have seen in some places. Commonly you might have observed. So because this is a common thing everywhere in the wind turbines. So there is a reason behind using. If you observe a wind turbine, we are going to use the turbine with 3 blades. Okay. So in 2 modes we are going to operate, that is upwind and the downwind. So the most commonly we will be having the 3 blades and will operate in the upwind. Will operate in the upwind. So this is the This is not exactly vertical axis, this figure. This is somewhat hybrid between this vertical and horizontal. Okay. So we can take it as example. So this vertical axis wind turbine come in several varieties. That is egg beater style Darius model, named after the French inventor. Egg beater style Darius model. So if we are having normally in vertical axis, we can say Darius and Savanius types. Okay. These turbines are omnidirectional, so they don't upwind or downwind. No need to bother. It will operate in the same manner, meaning they don't need to adjust the point into the wind to operate. So normally, if you go to the horizontal axis wind turbine, normally if you want to operate on the upwind direction, we have to face the wind. Sometimes the wind direction will change. So again we have to tilt and face that wind again. So that problem is not there for this vertical axis wind turbines. So in another type, so in which type? We can differentiate the wind turbines. So according to the design, we have told that horizontal axis and vertical axis. So based on the area we are using, we can divide into three categories. That is land-based, offshore wind, and distributed. So land-based, normally you might have observed, these are placed in the land. Offshore, these things you people may not have seen. So these constructed in the seashore, not on the land, in the sea waters near to the land. So there are advantages for the land-based and offshore wind turbines. And distributed are things where we'll place the wind turbine near to the customer. So the land-based wind turbines. So what is the thing here? So these land-based wind turbines range in size from 100 kilowatts to as large as several megawatts. So the capacity will be starting from 100 kilowatts to much more, several megawatts. So the large wind turbines are more cost effective and are grouped together into wind plants, which provide bulk power to the electric grid. So you might have observed these wind turbines are very large, very big structures. Why they should be like that? Why can't they? They can be with lesser structures. Means the large wind turbines are cost effective. They are cost effective. That's why we are going for larger and larger. So that is one of the reasons where we went for offshore wind turbines also. So if you go to the offshore wind turbines, so you can observe they are constructed in the sea. So these are much larger than this onshore wind turbines. These are massive. These are massive structures, and taller than the Statue of Liberty. They are more taller than the Statue of even the Statue of Liberty. In the sea, we can transport heavy things when compared to the land. Much more better way we can transport in the sea. That's why we can transport these heavy structures, and we can construct there. So they don't have the same transportation challenges of land-based wind installations, as a large components can be transported on ships instead of on roads. So instead of on roads, they are better. So we don't face much challenges like the land. The turbines are able to capture powerful ocean winds and generate vast amount of energy. So if you come to the land, there will be some natural things which may stop this force of the wind. The mountains, trees, even our buildings. So this will naturally stop the force of the wind, the speed of the winds. So in the sea, this problem is not there. So in the sea, the winds will move with high velocity normally. There is a much chance to move with high velocities because there are no obstacles for the winds. So in that case, we can capture the powerful ocean winds, and we can make use of that powerful ocean winds to generate the power. So this is the distributed type. So we went nearer to the customer. So when the wind turbines of any size are installed on the customer side of the electric meter or installed nearer to the place where the energy they produce will be used, they call as the distributed wind turbine. So normally in these cases we are taking these wind turbines to produce nearer to the customer. This will be having some benefits. And also, so if it is possible, we are going for a heavy, massive structures, very massive structures of wind turbines, because it is cost effective, bulk production. But even we have simplified this offshore to onshore, onshore to distributed. So if you can observe in the diagram, there is a small wind turbine here. So which might be enough for that small house. Which might be enough for that small house. Okay. So like this we have expanded from micro to macro level of designing of wind turbines. So wherever how much capacity is possible, how much amount of capturing of wind energy is possible, we are capturing. So many turbines used in distributed applications are small wind turbines. Yes, distributed means we are placing nearer to the customer. So naturally there we are using the small wind turbines. Single small wind turbines below 100 kilowatts. So this onshore wind turbines, if you go to the wind power plants, that is onshore wind power plants. So a wind turbine capacity starts from 100 kilowatts. So below that wind turbine capacity, we are using the distributed type. So single small wind turbines below 100 kilowatts are typically used for residential, agricultural, and small commercial and industrial applications. Yes, even though the capacity is less, this is a distributed method. The amount of power which is sufficient for my single home, if it is able to produce, yes, I can install here to my house. In my house premises, that's enough for me. So there is no need to install a wind power plant somewhere else or transport from some hundreds of kilometers to my house. This is some solution. Yes, if I am able to use it for a resident purpose, so if I am able to use some more small wind turbine, yes, I can use it for agriculture or small commercial and industrial or small scale industries. I can use. So the small turbines can be used in hybrid energy systems with other distributed energy resources. So if I am using these small wind turbines, the wind is not stable all the day, entire day. The wind is there, it is producing, I am using. The wind is not there, so it is a disturbance. There is an interruption of power. So then what I have to do? So I have to mix this wind power with other resources to cover this gap. So I can use diesel generators, batteries, and solar power. So the combination of this wind, solar, and battery, and diesel generators. So this will fulfill the requirement for throughout the day without having the power interruptions. So since I am using this wind, along with wind, I am using the battery, I am using the diesel generator, I am using the solar, photovoltaic cells. So all this mix. So I am calling it as the hybrid wind system. I am calling it as the hybrid wind systems. These systems are called hybrid wind systems and are typically used in remote. Yes, I can use in remote places. Places where the normal grid cannot approach. There also I can go. I can install a small wind turbine. I can install a small photovoltaic array. I can install a battery system. I can install a diesel generator. It's a simple solution for giving supply for need to the places where the grid cannot approach. So that means we can technically call it as the off-grid locations. We can technically call them as the off-grid locations. So Here is the diagram, which is showing the wind potential throughout the earth. See here, these orange color areas are the places where we're having more wind power. So this is from 4.5 to 7.2 watts per meter square. And this thick yellow color, you can observe here. Thick yellow, orange only here, chili. Afterwards, thick yellow. There are so many places. That is between 3.5 to 4.4 watts per meter square. And yellow. So that is somewhat less. And light yellow, some more less. And finally the blue is the area where we are having the less potential of the wind. So this is the data we'll collect from the weather reports. We are having data for some years, from centuries. This will help us to install the wind plants. It will guide us where to install the wind plants with what should be the individual capacity of a wind turbine. Which size we have to select, which model we have to select. Whether we have to select the Darius, Saveris or horizontal. So this data will guide. This data will guide us to the installation and production of wind power. This is very, very important. If you come to India, so again, this is the data we got. So these red places are the places where we can the speed of the wind is very, very high. Slowly from red to orange, orange to yellow, yellow to light green to green, again thick blue to light blue. So light blue places are the places where the winds will blow with less speeds. So based on this data, the census will plan to install a wind power plant. So if you go to the normally a wind turbine, we can differentiate into different parts. Okay, so the main thing is that we can easily say into three parts. So first thing is the head. So where we'll be having this wind turbine. Okay, or the mechanism, generator, all these things. and the supporting system. So you can observe here. So this is the supporting system. So it will provide the head to mount, and this is the bottom, which will support this supporting system. So three parts. So top, middle, and bottom. If you want this. Again, in this head, we'll be having different parts, different mechanisms. So like that. If you want to say simply, we can only say simply three parts: the head, and the middle part, and the bottom. If you come to the wind energy, so here we are not disturbing the anything in the atmosphere. We are just capturing the speed of the wind, and there is no pollution. So having no pollution nowadays is the one of the major one of the major thing advantage nowadays at this global warming situation. So still there is so much of research is going on in this field. So up to now, we have designed the turbines which are capable of producing the power, which are capable of capturing the wind power within a speed limits, and we have to. So that means it should have minimum some speed and maximum cutoff speed. That's all. So if the wind is in between these speeds only, this turbine is capable of producing. It's capable of rotating. So if high speed means operating at high speed will damage. Low speed means it will not rotate. The potential is not enough to rotate move that wing or blade. So still much more research is going on. So let's have a look what we have discussed. So first thing is wind. Why we came to the wind turbine? So there is so much of scarcity of electrical power. Still we have to produce more and more power, and we are searching for the alternatives of producing the power. So especially in the form of renewable. It should be renewable. It should not get exhausted. So in that searching, we found this wind-based power production, one of the best solution for the problem of electricity scarcity. So that is the movement of air is the wind. And what are the main reasons behind this formation of winds? So first thing is that the sun, who is not heating the atmosphere of the wind equally, is heating the atmosphere he is heating the atmosphere of the earth unevenly, and irregularities on the surface of the earth, and the rotation of the earth. So, okay, the wind is flowing, wind is moving. Why should the fan rotate? Why should the wing should rotate? So there is a force. So this is the wing. The force of the wind is coming like this. Why should it rotate? So it will not be exact like this. It will be tilted at some angle. So which creates an imbalance of pressures on the sides of the blade. This is the thing. This is making this unequal pressures on the sides of the wing is making the wing to rotate. Yes, of course, both the lift and drag forces are coming into picture, but the lift force is dominating. So that's why it is rotating. So once it is rotating, it is connected to the generator. So the rotor moves and the power is produced. That is the same thing as the remaining things. And majorly, what are the types? So the major types are horizontal axis and vertical axis. So if you go to the horizontal axis, we have to adjust the facing of the wind turbine every time the wind changes direction. So that problem is not there for vertical axis wind turbines. So, but the most commonly used things are the horizontal axis. This is having more production, and also we are constructing the huge structures of these horizontal axis wind turbines because that is the point where that is the way how we can have cost effectiveness. So that's why we are going for the massive structures. So vertical axis. So we can divide according to the placement, that is land based, that is onshore, offshore, and distributed. So in the land base, it starts from 100 kilowatts capacity of the wind turbine, and offshore much more than this onshore wind turbines, and distributed less than 100 kilowatts, and that amount of wind is not sufficient to operate for the entire day. So we are depending on the different things like photovoltaic and battery and diesel. So that's why we are calling it as distributed. Is generally is a type of the hybrid. So this distributed we are using in the off-grid locations where the grid is unable to reach. So these are the places where showing the potential of the wind power. And in India, so the speed of the winds. Okay. Thank you for listening.
Like, share and subscribe. Hit the bell icon for more updates.